Do you notice anything about the structure of the ducts and the structure of those macula?
First we're connected.
Well, that's sort of what it looks like. But how about their orientation?
The ducks, they all go in a different way.
So different ways, such as maybe up, down, side to side?
Sides.
And then, what about those macula? They're anti-parallel, right? Is that what that term is? Because parallel would be right beside each other, right?
Perpendicular.
Or perpendicular, there we go. I just couldn't come up with the perpendicular. Okay? For movement that we do, we have movement that goes up and down, right? Think about the elevator. We've got movement that goes forward and back, or side to side, however you want to look at it, like riding in a car. Okay? Now here's the thing about this structure. Alright, so we have our semicircs, okay? We have these two areas of macula. The one for vertical is macula seculi. Did y'all smell food burning?
Yeah, that's what I was thinking too.
Okay, so it's not just me. Okay. And then horizontal, macula utriculi. But now see, here's the cool thing about their structure. Note that they're trying to take what's existing right here, blow it up, and show us here. Because in movement that we have, movement is either being still, meaning static. This is for anything, okay? Think about a body of water. You either say that body of water is static or dynamic, moving or not, okay? Dynamic, moving. If we begin to take that section that they're showing us, okay, and look at the structure, we've got our connection to the vestibular nerve. Does everybody follow me? Once again, I have hair cells that are present, supporting cells that are around it. I've got this membrane over top. It's termed an otolithic membrane. Oto is for ear. Okay? Now, in this membrane, I have this fluid, and in the fluid, I've got what looks like rocks, granules. These are little bony pieces. They're otoliths, just simply meaning bony pieces.
And they just float around in there?
And they just float around. So, what's my equilibrium right now?
Static.
I'm static. Ooh, static clean. No, static. Right now, in that area of the macula, with the structure that they have, that fluid and those hair cells and the bones, bony pieces, the rocks. Rocks in your head. You got rocks in your head. Think about that for a second. You can literally tell people that now. Okay. Now, do you think that they're having to do any type of movement? No. But now I'm a body in motion. Okay? I'm gonna maybe. Hi. Okay? Now, here's what happens. When motion starts, think of up, down, side to side. Okay? Either linear, maybe swiveling around in this chair. When motion starts, it moves the rocks. If rocks begin to move, we've got motion in the fluid. But wait a minute. What else do I have right here? I've got some hair cells. And they are connected to what?
Vestibular.
Our vestibular nerve. So, if I begin to move, all right, note my rocks get shook up. Ooh, I'm all shook up. The rocks get shook up. Fluid moves. What happened to my hair cells? They bend. Well, if they bent, what do you think that started on that nerve fiber attached to them? The electrical impulse that's going to go by way of that vestibular nerve to the brain. Now, here's the thing. The movement of this fluid and the rocks that are in it, there's lag time. What do I mean by lag time? Let's say that I sat there and I swiveled around in the chair, and you get up and walk. Takes you a second, right?
Mm-hmm.
It's your lag time. Basically, that fluid getting settled out as well as the rocks behaving. They've recently found out that people who have inner ear problems and have this vertigo, that they can do physical therapy now. You go to a physical therapist, and now granted, they put you in some crazy positions, okay? But what they're doing, they're shaking up the rocks, repositioning them. And they say it helps the vertigo.
So when you're on a boat for a long time, and then you get on shore, and you're walking around,
You gotta get your land legs back.
So is that the rock still trying to?
Still the lag time trying to catch up.
So like the next day, when that
Yes.
happens, it's still lag time?
Yes.
Wow.
Believe it or not.
So how does Dramamine stop that?
Dramamine, I'm guessing, stops the passing of the impulse along the nerve. Somewhere it interrupts the impulse.
And the ones, the bands?
The what?
The bands that they put around? I don't know how they work.
Those are pressure
Um,
points.
They have
The what?
They're pressure
they're
points for
pressure
certain,
points.
yeah.
Yeah, and my guess is the pressure on that particular nerve affects another nerve to stop the impulse, or direct information elsewhere that you know, so it's like paying attention to that rather than this stimulus. Yeah, that's my guess.
So they always say, like in smokers, it affects the hair inside of the ears. So are smokers like more likely to have like
Smoker's ear?
Yeah, that's what I've heard. Is that it damages the hair cells inside of your ears. It's over a long period of time of smoking that you can eventually get hearing problems from smoking.
I have never heard of smoker's ear, but I will look it up. And I forgot what I was supposed to look up about migraine.
The lie bomb too.
Oh, I did. I looked that up. It is one of those papillae inflamed. Yep, and that's why it's so painful, because it's right there too, you know, the connection of nerves and stuff.
But it has nothing to do with lying, right?
Not that I understand. Not that I understand. It is an inflammation of those little papillae. Yep. So if we think about the movement, okay, that's going to happen, those macula, remember how I pointed out, one was vertical, one was horizontal, okay? So when we look at it, the one that's vertical, like I was saying, up and down. Horizontal, linear. Think of like maybe moving forward in a car or moving back in a car. Now, in those hairs that are present, they're going to have what's called a kinocilium. It's the only one true cilium that's there, okay? The other one, even though they're considered cilia, they're not true. But in the patches that are present, the patches will have one true kinocilium, one true cilium. That one that's embedded, that can pick up the information and pass it along the vestibular nerve. So those little rocks, okay, the little rocks, if they go into motion, and then we've got the fluid, we begin to see bending of those hair cells. When we bend those hair cells, we're going to have the passage of information along that vestibular nerve. So when we're static, everything is kind of nice and happy. If we begin to move the head in any way, we upset the fluid motion and we upset the rocks. Okay? So what'll happen is hair cells bend, bears down on them. It's a brief lag time, okay? Because I don't know about y'all, like whenever I'm at the elevator, and it's really bad if the elevator stops on every floor, okay? If it has to stop on every floor, by the time I get off that elevator on the 6th floor, I'm still moving up and down, okay? And for me, it can last actually several minutes. Like I said, there's something wrong. Maybe I need to go have my rocks repositioned, okay? But we get that bend. Basically, the information that's going to pass to this vestibular nerve, remember the vestibular nerve meets the cochlea, okay? And we're going to make sense of that information, and that information is important for helping maintain body posture. It's to keep us from falling over. Take a break, be back at 12:30.